So, present. There we go. Okay. So it's not a bird's eye view, it's a snake's eye view. I'm going to minimize that. Okay. Hello. There we go. Okay. So Python, oh, I can't see my speaker's notes when I have it like this. Anyway, I'll try to do this without my speaker's notes. Python was originally created in the 80s by a guy, the delightfully named Guido van Rossum, who's a Dutch computer scientist. And my understanding is that he wanted to create something that would be usable by kind of anybody who needed it. And so originally Python was kind of aimed at, I don't want to say hobbyist, but it was intended to be a language that you could pick up pretty easily and use, maybe not for the prettiest stuff you'd ever seen, but you could use it to get stuff done. I need to see my notes, sorry. So it's actually called Python. I think this is a little taste of the world of Python. It's actually called Python after Monty Python. I had no idea about this until just recently. And in tribute to that, a lot of times, especially in like the older Python docs, instead of using foo and bar as variables, they'll actually use spam and eggs, like the spam, that sketch. Anyway, I thought about showing it, but I think it's actually not that funny. One of the big things that people who are really into Python like to talk about is what they call the Zen of Python. And anytime you are operating in a Python environment, so I've got my Python virtual environment going here. That's what this VENV is. If you type the command import this, and then you run, what have I called this? Oh, I've got to navigate, sorry. Anytime you're in Python, if you run, you will get this. If you run import this, you will get the Zen of Python. So this is, can you guys see this, or do you need me to make it larger?
You can maybe zoom a little bit.
See if I can figure out.
Like one or two. Maybe just one.
How do I do that? Oh, there we go. It just lagged.
Perfect.
So the Zen of Python, this is how Python is meant to be. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Practicality beats purity. Errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now is better than never. I'm not really sure what that one's meant, what that means. Although never is often better than right now. If implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. It's worth noting, well, I don't actually know if it is worth noting. There are 19 of these statements in the Zen of Python, and everybody always says that there are 20, but the 20th one isn't printed. I don't really know, again, what that's supposed to mean. But there's sort of a like cult around Python. But this gives you kind of a sense of, I don't know, I would say like the intent of what people are doing with this language and why people like it and what people are striving towards. And if you can, if your code approximates all of those virtues, they say like it's Pythonic. And in general, like the Python community really discourages being clever. Like it's, somebody told me once, so this is going to be, I don't know if this is going to make sense to most of you, but Edison and Tesla, you know, when they're like kind of wrestling over the future of electricity and the electric grid, Edison had this very, like his approach, and which is the one that won out, it was a very like, we have this thing and it works, we're going to duplicate it, and then we're going to duplicate it again, and it's just like little chunks, like little mechanical building blocks, very easy to understand. Tesla had this like grand vision that was like much harder to create, like a little neat proof of concept. Python is Edison. Python, like Pythonic code, is code that is easy to understand, clean little chunks, nice proof of concept. The code, wrong, what am I looking for? The code, well, this is not actually a very good place to show it, but uses indentations pretty heavily. Oh, I've got my terminal way up, that's what's going on. So that, and in, you can't, there aren't, if you look, you notice there are no semicolons, right? So every line break and every indentation in Python code is actually part of the code. And what that does is it forces a certain like separation of logic and visual organization that you don't necessarily get in every language. And I think that's part of what makes it a little bit easier to parse up front, although I will also say that I think it can be kind of ugly. Okay, so that's the rough overview of Python. And look, here's my duck. So in terms of the characteristics of the language, Python is a single-threaded language, but like JavaScript, there are a million ways to sort of work your way around the single-threaded nature of the language and make it act like a multi-threaded language, which a little bit runs contrary to that idea that there's only one way to do things, but I'll talk about that more in a minute. In terms of typing, Python is, it's neither strictly typed nor weakly typed. It is what they call duck typed, meaning if it looks like a duck and it talks like a duck, it probably is a duck. Types in Python start out weakly typed. So it's what's called dynamically typed. In practice, it functions like a strongly typed language after you've established the type through your code. It's a little bit hard to explain, but what it means is that it is both highly flexible and highly predictable, which is one of the real benefits with Python, and part of what makes it really good for math and data science, which is kind of one of the big use areas right now. So Python is a multi-paradigm language. You can do object-oriented programming. You can do functional programming. It's got list comprehensions and map, filter, reduce. It did not originally have those, but it has them now. It is, sometimes people call it a batteries included language, meaning it comes with a lot of functionality, a lot of features kind of built into the basic libraries. But it's relatively lightweight compared to some. One of the big things that makes Python kind of unique, not totally, as a former English teacher, the fact that I'm saying this makes me crazy. It's not totally unique, but it's kind of unique, which is not what the word unique means. Anyway, Python is great for learning. It's great for wrestling with data, for kind of figuring out how things work, because it gives you access to what's called the virtual environment and to something called notebooks that I'm going to show you in a little bit. So if you learn Python, you can use it for pretty much anything. However, I don't think it's great for almost anything except math. One of the big things that Python developers will complain about incessantly is how messy the dependencies can get. Python out of the box, like I said, is fairly full-featured, but to do almost anything on this slide, you need to install all kinds of dependencies, and it's really sensitive to like what order you install them in, what versions you have. It's just an unholy pain in the butt dealing with Python dependencies. And it's sort of like the cost you pay, the price you pay. But I think it can be a real barrier for beginners. But once you get through it, it's not too bad. The other thing I really hate about Python is that the front end capabilities are terrible. And that goes back to the fact that the language was originally made to be kind of, I don't know, almost like an academic language. It was not designed, like the language was not designed for the modern web. And they've certainly tried to adapt it and make it more flexible for the modern web. But the templates that come with most of the frameworks, with the like popular frameworks, are really awful in my opinion. They're just not very flexible. It's really difficult to do any kind of like modern looking design. It's just not pretty. The other thing that I think holds Python back, so that whole thing about the Zen of Python and all those lovely principles, is that they are principles. They're not practice. And I think the one that gets me the most is this, like there should be one and preferably only one obvious way to do it. In practice, because of all of those dependencies and, you know, just the multitude of different modules and libraries and whatnot that you might use with Python, and all the different framework options, there's never only one way to do something. And when you move from one Python project to another, you might think that you're going to be able to like cross apply the principles of how things are organized. And it just doesn't wind up that way. And I know that's true in every language, but I think it bothers me more in Python because in theory, it's not supposed to be that way. And the other big beef that I have about the theory of the Zen versus the practice is like that readability thing that I was talking about. I frankly, this file isn't too bad, but I think that Python can be really, really ugly to read. And I think maybe because of the academic background and maybe because of like a tendency to want to do everything briefly, for whatever reason, there's this convention of using these like 1 and 2 letter variable names that I just don't think it actually winds up being that readable a lot of times. So I have beefs with Python, even though it's really good for a lot of things. So I'm going to talk a little bit about frameworks, but maybe before I do, I'll pause and see, does anybody have any questions?
Not
So
so
far?
much a question, but wanted to touch on one thing. Actually, I love how opinionated you are about it, because I feel like we should have opinions about the things we use. I have many thoughts on this, but I did want to cover one thing, the sort of the typing, just for a little more context. So, like, generally, we can put languages in 2 places. So there's the strong versus weak dichotomy, and then there's like the static versus dynamic. So to contrast, like, Python, like JavaScript is what we call weakly typed, because JavaScript has like type coercion. Something can start acting like a string, but if you call it something else, like JavaScript will try to coerce it into a number or an object or something else like that. Python is strongly typed in the sense like it doesn't do that. As Julia said, once it's like, oh, this is an int, you can't do string methods with it. It will throw an error. It won't try and like do that implicitly, which is almost all the time the preferred behavior and like saves you a lot of headaches. Implicit conversion is very interesting. But the languages are similar in the fact that they are dynamically typed versus statically typed, which just means like at what point is the type information known? Instead of being known at compile time, it's known like at runtime, or, well, Python does like a compilation and interpretation. But
yeah, that's a better explanation than mine.
No, yours is good, but I know it's a thing that people, it's very messy.
Well, and I would say this is another like little bit of a plus and a minus about entering into the world of Python. It is like people who are really into it are really into it. And there's a little bit of an obsession with like making it seem really unique and like, oh, the way Python does things is so different. And I guess part of my point is that, yeah, there are some unique aspects to it, but by and large, it's really not that different than anything else that's out there. An obsession with it. Yeah. My brother-in-law is a Ruby developer, and there's a lot of similarities between Python and Ruby in general. He's like, well, you might want to consider learning Ruby because it's a little less like, this is the gesture he made. It's like the Python community is a little like, I don't know, geeky. But I think I was going to mention this at some point in here. The upside of that is that the docs are fantastic. I think the docs for Python are better than for any other language I've worked in. People love it, and so they put a lot of time into really high quality open source documentation. Okay, so frameworks. And I put frameworks plus because one of these isn't really a framework. There are actually many more frameworks than this than you can use with Python, but these are kind of the big ones. Except Jupyter is not a framework at all. So I'm going to go through and just talk about each of these, and I'll show you examples of a couple of them. Okay, so the big one is Django. Django, again, with the Python people like to be different. Django is called an MVT framework, not an MVC framework, but for all intents and purposes, it is an MVC framework. What MVT stands for is model view template, as opposed to model view controller. Confusingly, though, the views in Django are actually the controllers, and the templates are the views. So if we wanted to make these more parallel, it would be like MTV versus MVC. Hey, look at that, MTV. But if you ask me, it actually should be the MVC should be MCV, because you take your models, you send them through the controllers to the views. And in Python or in Django, you have your models, you manipulate your models, pull out whatever data you want through the views, which I don't know why it's called that, and then you send the data to your template. It is server-side rendered. This is your framework for traditional web apps. It is, like I said before, it's not a very modern front end. The Django templates are clunky, and I don't know. I've worked a fair amount in .NET, and the templates, the like Razor templates in .NET, I think are just so much better than Django templates. I don't know, Kirk, what do you think?
It's funny you say that, because I feel like there are certain aspects of .NET where I feel like the templates are even farther back than.
Well, yeah.
I haven't played with Razor yet, but I've heard good things. So that definitely feels right.
So the Django templates have some of the I don't know what to call, like where you can actually run code in your template the way that you can with Razor, but it doesn't have as much functionality, and this is a really like minor thing. I love the view bag in .NET, and there is no view bag in Django, at least not that I've been able to discover. So what has become, I think, a more powerful option, and it's not applicable in every case, but what has become, I think, the more powerful, more modern option is to use what's called Django REST framework. Django REST framework takes that Django MVT and layers on RESTful API tools. It has really, really nice built-in serializers to create endpoints from your models. And this is the thing that I maybe love the most about working in Python world. That is the web browsable API. This just comes out of the box with Django REST. And if you have ever worked on a project where someone was like, can you create me an admin portal for this, for our database? And you're like, oh, what? That's so much extra work. Use Django REST and you get right out of the box this beautiful admin template. So this actually just works right off of your models. This is like, if I went into this project file, I would see in my models, I have groups, I have users, I have businesses, categories, organizations, etc. And in terms of actually adding data to the database or seeing the relationships between things, let's see if I'm still logged in here. Oh, weird. Okay, this is a project I haven't worked on in a while, so it's possible that, yeah, look at that. Well, that's not a very good demo. Anyway, I would be able, yeah. So all of my model fields are just here, and I can enter data in here. So this is a project where we have this big like scoring rubric where you enter responses to surveys in this questions category, and then the scores filter up to the businesses so that you can get these category scores for the businesses. And that's the kind of thing that like you might ordinarily have to create kind of a complicated admin portal in order to input the data that would then go to the consumer side public facing app. Django REST, you don't have to create that portal. It's just here. And just in terms of like kind of any database intensive kind of project, you can just, it's just nice, I think, to be able to visualize it and see how things are relating to each other and monitor your data in this other format that's a little bit, I don't know, I like it a lot. Then, so that's Django REST. Oh, and then the big thing with Django REST is that because it's an API, you can consume it however you like. So the big thing that I've been encountering recently, I've worked on a few projects where people have been doing this, using Django REST and then having a React front end, that allows you to have all of the benefits of Python in the back end, but to create your nice modern looking single page front end. So I'm a big fan of Django REST. I am not a big fan of Flask. So Flask is a very lightweight framework. I was talking with a couple of people last night about a job posting where they wanted somebody with Flask experience. And I was like, that's weird. Like Flask is, it's so lightweight that it's extremely easy to learn. There's really not much to it. What's cool about it is that there are no limits on extensibility. Virtually all of the modules and libraries, whatever that you might want to use with Django, you can use with Flask. Managing all those dependencies can be, like I said, kind of an unholy pain. The big thing with Flask, aside from the templates, which Flask usually runs with something called Jinja 2 templates, which are just a variation on Django templates that I think are also frustratingly limited. The big thing about Flask is that it just doesn't, it's how do I want to put this? It doesn't take a lot of stress. Well, like you can't really run really large scale stuff on Flask without experiencing some performance issues and reliability issues. So what it's great for are simple internal apps that you are not going to be showing to a public audience. It's great for like proof of concept kind of projects where you just want to spin something up quickly and be able to say like, this is how it would work. Yeah, we didn't create, a big data storage system. But, if we were to add that on, we could easily take much of the code that we've written here in Flask and move it to Django or whatever. So the job where they were looking for Flask experience was with a manufacturing company. And it actually makes sense, right? It's like, okay, they are a company that makes things that they sell. And so Flask is probably something that they're mainly using internally, maybe monitoring data that comes back from devices, something like that. So I recently did a project in Flask, which I will show you a bit of. And I guess I just would say it doesn't take that long before you run into the limits on Flask. The other thing I want to talk about, and I'll show you this as well, is Jupyter Notebooks, which this is the other thing that I heart about Python, the Python world. There are other languages that have notebooks. There are other notebooks for Python, but Jupyter Notebooks, I think, are really nice and easy to use. And kind of going along with that idea that like Python's great for learning, it's great for proof of concept, it's great for kind of playing around with data. This is a big tool that people, data scientists use, is the Jupyter Notebooks. So I have this project that I've been working on that is, what we're doing is we're taking audio files and we're uploading audio files and then running them through a speech recognition library called Deep Speech. That's a Mozilla. That's what this is. It's a Mozilla library and it's a huge thing. And then we are also processing those same audio files with another library called Librosa. And oh, that's where's my file that, there it is. So Librosa is primarily like a music production thing, but we're using it to look at various different characteristics of the audio signals, to try to identify different types of sound within an audio file. So this was a fine application for Flask because we don't have storage, like we're not setting it up with authorization at this point. Like we just wanted to have a website where you could click like upload my file, click a button that would run, run it through the deep speech functions, run it through the Librosa functions, and then spit back just the data output as a CSV file. So it's not real like beautiful graphics or anything like that. But Flask had everything we needed to do that, right up until the point that we wanted to actually make it look nice. And it's just really challenging. And then also like Flask out of the box doesn't necessarily work super well with a lot of database options. It works really well with SQLite. But for storing large files, it looks like we're going to have to move and maybe work with something like move this over to a different framework. So either that or use some kind of cloud storage option, not our own database. Or I don't know what I mean. Anyway, so what I wanted to show you, I'm kind of losing track of what I'm talking about. What I wanted to show you is the Jupyter notebooks. So what I did here is I took the same code. I took the same code that's here in this file. And if I wanted to run this in here, so the stage that I'm at with this right now is that I'm kind of running through and testing all of these different functions and trying to tweak the filters that are based on each of these functions. And so I'm running it many times on different files and just kind of looking at like the way that things shake out. And it's just a lot of basically trial and error. And if I run it directly through here in Flask, I'll show you what happens. Is that in? Okay. So it's going to take a minute. It's running. It's running. Oh, whoops. Oh, shoot. I changed a bunch of stuff. Never mind. I can't show you this right now. Or maybe I. Oops. I'll try it one more time. Heck. I don't know what I just did. How do I get rid of that quote that I accidentally typed? Anyway, all right, never mind. If I were to run this here, it takes a few minutes and it spits out like just a billion charts all at once. And it's kind of chaos. And every time I want to test something, I have to run the whole thing and it's just ugly and I hate it. So instead, I moved all of this stuff into a Jupyter notebook. And Jupyter notebooks, it's just, you just install Jupyter in your Python virtual environment. And anytime you want, you can open one up and take any code that, or how do I want to put this? It exists in the same environment as your project. So you have access to all of the dependencies that are installed in that virtual environment in that project. So I'm using a number of tools that are like math focused tools. Matplotlib does data visualizations. Numpy is for large scale mathematical operations. And then I've got Librosa and IPython as well. So what I did was I moved a lot of my code in here, and then I can just go through one clip at a time and declare like, okay, the clip I want to use this time around is clip 8. And then you can intersperse your code blocks with markdown blocks. And if I run that, you can see it creates something that looks pretty polished. And this is just for my own use. So I didn't do anything very fancy with the formatting, but you can put in graphics. You can do anything you wanted to do in a markdown file. So you can produce some pretty nice looking reports with runnable code built right in. So I'm going to change this and run it on a different clip. And then I click run, and now that has reassigned the value of that variable. And then what I can do is, let's see, how long is clip 7? I click, oh, look, it's 11.1 seconds. I want to see the wave plot now of clip 7. I click run. There it is. And then I can put in explanations. So let's see down here. I have this thing that is making me crazy called the zero crossing rate, which is a Librosa thing. And I had to do a bunch of mathematical adjustments. And so I just kind of explained for my own purposes here, like what those adjustments are. And then I did the math here. Oop, look at that. And then, then I have another code block. I can run it, get a new graph. And then what I actually learned is that all of that work really didn't matter at all. And so I wrote the explanation there for myself. So as I'm going through and like testing all of this different functionality, it's just a really nice way to be able to see if you're working on something with data visualizations, or you're working on something where you're running different data through some functions and you want to see the results. Notebooks are just a really nice way to be able to kind of manipulate just little pieces, write down your observations, have it all in one place. And then you can save this, print it, save it as a PDF, share the whole notebook, whatever. So it actually also makes a really nice presentation format. So at some point, I'm going to go back to my product manager on this project, and I'm going to show her this notebook and be like, I don't think I can do that thing that you want me to do, which is actually my conclusion after all of this work. But it's easier than having to write up all of the front end code to display all of this stuff, like, web app, because I can just do it right here. I can write my commentary and kind of organize things the way I want to show them. Okay, I think this is what happens when you don't rehearse your presentations. Just really briefly, the other thing that I think makes Python really unique, and that is why I wound up working in it on this project, because Python started in this very academic world, anything under the sun that you can think of that you might want a library to manage, Python has that library. I just was sort of I wonder if there's a geology library for Python. So I typed in geology library, Python. There's multiple. This Librosa, there is nothing like Librosa in any other programming language. It is the state-of-the-art audio processing library, and it exists for Python, not for anything else. There is just any kind of data visualization or mathematical operations or statistical manipulations, whatever. Those tools exist in Python. They are super well documented, and they are really easy to use. And so that's what a lot of these are: matplotlib, pandas, data frames, PyTorch, numpy, scipy. Apparently you're supposed to say this numpy, but I call it numpy. Yeah, And that to me is the real benefit of learning Python. If you have some pet project where you're like, I would love to be able to work with weather data, there's a Python library for you. And it will be well documented, well supported. There will be a community of people working in that area who want to help you. And that I think is really valuable. So with that, I will take only a couple minutes for questions. Anybody?
Yeah, I actually have a lot of questions, so I don't think we have time for them.
Well, feel free to, I mean,
I'm gonna ask you, because my friend has me doing a database project, and I know nothing. Like a month ago, I didn't know what a database was. I didn't know what a server was. So I have a database and I'm trying to learn PHP, but you know, there needs to be a front end for the app.
mhm.
So, you know, Python might be the way to go. I don't know.
Yeah, I'd be happy to talk to you. I mean, I don't know if I'll have answers, but I'd be happy to talk to you about that.
Yeah, I mean, everything I'm doing, I have to learn. So I might as I know some Python. I'm doing machine learning stuff. So.
Yeah. Yeah. Does
With the
anybody else
notebook.
have any? I mean, I can stay for a couple minutes too.
I was just gonna say, Julia, if you're okay with it, I can also hang out for like another half hour or so.
Yeah, absolutely. I have no other pressing things on my schedule.
I do. So I'm going to go.
But yeah, feel free
was
to
great.
post questions.
In the Slack. while we're
On
there.
Slack.
I will, because I think, you know, this might be an option. Because I want something other people can look at and understand.
Yeah, and that
This
is
is a project I don't want to own.
I think the other thing about Python is that there are a lot of people who are not developers who still know a little Python. So it's nice in that way.
Cool.
Yeah,
Okay,
and I just-
bye.
Later, Chris. One of the things I feel like, first of all, Julia, thank you so much for the
Absolutely. I don't know.
I think that was a great like snapshot of Python, especially as it is right now in the modern world.
Yeah.
I also really I like people who, I mean, it's good to be like, yeah, this is all great, but you know, I do like the fact that you also share like your experience of it. Like, this framework felt good, this did not feel good. Because I feel like, especially when you're getting into something, it's, you know, it's hard to make your own determinations before you've had a chance to actually use stuff. So if somebody has more experience, they're like, hey, well, this is what I did, you know, that's at least a starting point, which I feel like is
What I figured. I mean, like I said, there's just so many choices there's some languages where it's like, choose this or this. With Python, it's like, the world is your oyster. Like, here's a buffet of options, and it can be a little overwhelming.
Yeah, it's the ecosystem is growing in such an amazing way, and I think that's to the credit of Python. I feel like the biggest thing about Python is that people who write Python like writing Python. So, you know, like I feel like so many people, I know their origin stories of like package managers. Well, you know, I wanted to do this thing and I didn't see it yet, so I made one. You know, like that's a very common Python story. And the notebooks, I don't know if sometimes I feel like people don't realize that Python notebooks, because Python is a language that I learned when I got into programming, and the notebooks were a game changer for me, because I feel like with every other framework, comments and documentation are just like completely orthogonal to the code. There's the code, and then there's like the comments, and in notebooks like seamlessly go between, you know, like I love them. I use them for like small projects. I use them for documentation, and you can, you know, here is the write-up of the thing I did, but oh, by the way, you can just run the thing I did, which in the scientific
here. Yeah.
it's like, instead of, oh, well, people talk about the data the science they did, like you show the charts, it's like you can run the charts, like you can see if I did it wrong because it's literally right here.
And you can go in and you could change one number and click run and see what changes. And that to me is really powerful for anything where you're working with data manipulation.
Interactive. Have you used .NET Interactive?
I have not.
Yeah, .NET, I mean, so F#, which very much feels like the functional cousin of Python.
Yeah.
They've been interested in the data science aspect, and they enjoyed the concept of notebooks so much that there was a port, there was like a Jupyter version of F#. Yeah, but now there's just like a full .NET Interactive.
Oh,
and
cool.
Yeah, that's just there. Like
I've heard of it, but I haven't used it.
I don't know
That
if
would
it's
make sense. I mean, yeah, like anytime I've ever tried to do any math in a language other than Python or C#, I just want to stab my eyes out. Math, and I don't know.
Yeah, so there's .NET Interactive where you can set up, I think, C# notebooks, F# notebooks, maybe VB notebooks. I don't know if they have that functionality yet. But it's like a direct port, because like, oh, this Python thing, this is great. The rough part was just like before you basically had to get Python to get Jupyter to run it. So they're just working on their own version of that. That's pretty cool.
Anybody have any questions, comments? Well, you're welcome.
It was good, you know. I also like, showing the actual projects, which I thought was pretty valuable as well.
I don't know what happened. That one that I went to show you, the site administration, I haven't worked on that project in a while, and it appears that they may have taken my access away. So, oh well.
I mean, live demos are a bold choice at the best of times.
Yeah. Well, I figured this is a very accepting, forgiving community, so I did my best.
Yeah. I saw you're using virtual env. Have you tried like any kind of like compare and contrast between that and like PyEnv? Which runs like virtual Python versions or something on different computer, like on the same computer, you can run multiple versions.
Oh, so like if you're running Python 2 and Python 3?
Yeah.
I have not, but I could certainly see applications for that. Yeah. Interesting.
I had somebody at work install. They used that for me, and they installed it for me, and I don't know which one is better for kind of like working on it. If there's what the pros and cons.
Yeah, I'm not sure on the answer for that. I'm trying to remember which one is older. I want to say VN is older, but don't quote. And it's like going back to what Julia said. Like very often in the Python community, you will find like there was one library which was super popular for a while, and then someone will sort of do a more modern version, and then like that becomes like the new face. Like with HTTP requests, like we have requests now, and requests are, everyone's like, use this. But before that, we had the old like HTTP lib3 one, which like is still around everywhere just because it was like ubiquitous until the new one came out. And I feel like that's where VN and PyEnv are right now. We'll see which one comes out on top.
Yeah, I know I've seen it. In use. I've never used it, and I'm not really sure. I don't know. I'm not sure what limitations they have in VN that it would address.
I don't know. I just know that you can set a virtual environment and then set which one runs what version, and you just install it. But yeah, I found package management to be a pain in the butt.
Oh, it's just
I hate it.
there was a while there where like every 3 days somebody else would post in help and pairing, like, what the heck is going on with Psycho PG2? And I was like, oh,
Yeah,
Ooh,
like,
before-
that and like importing of things as well, like not just your package management, but when you import between classes and other like.
I know that was a thought that I had when I was looking over that the Zen of Python, like the last one, namespaces are great, let's use them. Like, yes, let's. Because
before we
why?
dive a little more into it, let me just do the outro really quick. I know a lot of people like to pop off. We don't really have like an official time for these. It's like 45 to 90 minutes. So yeah, it's usually like if the speaker isn't like bogged down, we go for more. But yeah, just before, I just want to wrap up and say, not wrap up the talking, but just to say, I want to
I'm sorry.
explicitly
I'm gonna.
tell Julia thanks for being here and for presenting. And this was I think like a really sort of delightful intro into the language. And yeah, if people enjoyed it, then we can talk more about it in the Slack and GitHub issues and VC Coffee. And I think our next one will be on the 20th, where we have Jesse Shakarian talking about chess and AI. So that would be awesome, and definitely looking forward to that. And if anyone has any questions, you can reach out to the community maintainers of Virtual Coffee. We're always here to support. And yeah, and with that, I am going to